A circular racetrack of radius 50 meter is banked at 30 degree. So this one is 30 degree, and if this is the racetrack, if the coefficient of friction between tires and track is 0.8, we have to find the greatest speed with which a car can go around the track. So if we take the car like this, the normal force, let's call it Fn, it will have, this is the vertical plane, so this is the horizontal, and so this angle is there, which is this one, is 30 degree. So this much is 90 minus 30 degree, 90 minus 30 degree, and this much is 90 degrees, so this angle is 30 degree again. And if we take the frictional force, which is in the horizontal direction, it is like that. So this one makes 30 degree with the horizontal line, and like that. So this one is this is the horizontal line, this one is 30 degree there, and its vertical component is there and the horizontal component is in that direction. So we need to find the greatest velocity. So if we take the horizontal forces, sum of the horizontal forces at play and sum of the vertical forces at play, they will be equal. The horizontal forces will have to balance, and the vertical components will have to balance. So first we take the horizontal components. So the vertical component I will take first. So Fn, and then it is making 30 degree with the vertical line, so Fn cos 30 degree. Then Ff, which is the horizontal frictional force, which is in this direction, and we have to take the vertical component, but it is in this direction. So if I take the upwards direction, it will be negative, and it will be Ff sine 30 degree, because this force, the frictional force, makes 30 degree with the horizontal line, so that equals to mg. That's there. Then of course the centripetal force is in the horizontal direction, that's mv square over r. So if we take that, this one it is this one. So when we take the horizontal components, the normal force, which is Fn, it makes 30 degree with the vertical plane. So Fn in the horizontal direction will be sine 30 degree, and plus this is also going in the same direction, in this direction. So these two will be equal to they will make up the centripetal force, the horizontal forces. And as the frictional force, the horizontal component will be Ff cos theta, because cos 30 degree, theta is 30 degree, because it makes 30 degree with the horizontal plane. That will be equal to mv square over r. Now frictional force, it is said that the frictional force is frictional coefficient of friction is 0.8. So F frictional force will be equal to 0.8 of Fn. That's what it means. The frictional coefficient is 0.8. So if we plug in those values, it is in these two equations. So Fn times cos theta 0.866, and then minus 0.8 Fn 0.5 is equal to mg, and then this is equation 2, it will be Fn times 0.5 plus 0.8 Fn, because instead of Ff I am writing 0.8 Fn, times 0.866 equals to mv square over r. So these are the two equations. So if I divide these two, maybe dividing this one by this one gives me, so that will be fn we can cancel because we can take fn outside the bracket here and they get cancelled. So f mv square over r over mg, and this is 0.5 plus 0.8 into 0.866, and in the denominator it will be 0.866 minus 0.5 times 0.8 basically. So m is getting cancelled, v square will be g over r. G is gravitational acceleration, which is 9.8, and r is the radius of the track, which is 50 meters. So this one times 0.5, basically this one, I am not rewriting this, so this one and then square root, we get v to be 35.4 meter per second. So that's v after square rooting. So that's the result. So what we did here is we took the horizontal force. I will probably write this down again here. So this is the horizontal vertical Fn, and this is Ff. Now this one, this is 30 degree, and if we take a vertical line, this much is 90 minus 30 degree, 90 degree minus 30 degree, so this is 30 degree, and it is making with the vertical component. That's why the vertical components had sine theta, sine 30 degree, a vertical component of Fn, and horizontal cos 30 degree, and the horizontal component has sine 30 degree, because this one is making 30 degree angle with the vertical line, and here this one, this is making 30 degree with the horizontal line. So the horizontal component had cos 30 degree for Ff, and vertical component had sine 30 degree, and this is the vertical component is going downwards. That's why we had the negative sign here, because these two are upwards forces, and this is the is equal to mg, where it is this one, mg is the downward forces, downward force, the weight. So that's why we that's what we did here. Since this is inclined, we needed to take the vertical components and horizontal components and equate them, because for equilibrium they have to be equal. The vertical forces, vertical components will be equal, will be so upwards downwards will be equal. Similarly, towards the left, towards the right will be equal. So in this case, the horizontal component, what they did is these two forces, the horizontal component of the normal force and the horizontal component of the frictional force, these two make up the centripetal force. That's why the sum of those two will be equal to mv square, which is the centripetal force. So yeah.